students?
Yes, sir. Yes, sir.
Okay, okay, fine. So when we have a computer, all of you know that the computer works on which architecture? It is typically a von Neumann architecture. So what is a von Neumann architecture? It's a very simple architecture it has an input device, it has an input device, it has a processing unit, and then it has an output device. So that is what is the von Neumann architecture. So if we see the images of it, and if you see, so this is typically the architecture of von Neumann. It has an input device, then the central processing unit, and then the memory unit and the output device. So input device is our keyboard or a mouse or even files, the inbuilt files, and this can be the input device. The memory is the data is the processing actually happens into memory, and the control unit. The control unit fetches the data from memory, and the memory, you all know that it is divided into three different hierarchies: the secondary memory and the primary memory. Okay, and primary memory means the cache and the RAM. You all know that, a random access memory, and the output devices could be the monitor or even could be the file. Okay, in which we write the output. Now, so when we load a program, so that goes into memory. You all know that. Okay, so when we load a program, that goes into memory. And a memory is typically like this. Okay, so a memory is typically like this. It has the, you can call it, this is a typically a memory in which every is a single bit that is stored, and this forms a one word. Okay, in terms of memory. So this is a word, or you can call this as a, you can call this entire thing, this as a word, and this in a small part is a single bit of it. Okay, and the word can be based on either 8-bit or 16-bit or 32-bit or 64-bit. So based on that, that forms the word. So that typically forms the memory architecture of it. So if it is a how the memory it is. Okay, so based on that, the number of bits that forms one word. Okay, and you all know that 8 bits forms 1 byte. Okay, so how many bytes are present to word, that depends on the architecture of the CPU architecture. It is a 64-bit architecture, 32-bit architecture, the hardware. Okay, and that even then the based on the operating systems are also 64-bit and 32-bit. Okay, so you will understand these terms later when you will understand computer organization into a second semester, in which you will understand how the architectures are different. 32-bit means what, 64-bit means what, architectures. Now, let us coming to a point of linked list. Now, we know that the organization, memory organization or handling of the memory is done in two parts. One is the static memory allocation, and second one is dynamic memory allocation. Okay, so what do you mean by static memory allocation? The static memory allocation is that it is a term that the memory is pre-allocated. For example, if I write in a C programming language or in C++ programming language, if I write integer a and 10, so what does it mean? It means that in the memory, the a variable is created and it is of type integer, and the 10 locations are allocated. So if it is a memory, then this will be the first location of the first so 10 locations. So 10 locations will be allocated. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and this last one is a 10th. So that location. So these are the 10 locations, and these 10 locations are sequentially allocated, one after the another. So you can address it by the location 0, location 1, location 2, like this. Okay, so till this last location as 9. So this is called as indexing of it, or you can call it as a memory addressing of it. For example, if you want to access the first element of that memory, then you can access it as a of 0. So that becomes the first location of that variable. Okay. Now, the problem with this is that sometimes the the memory, once it is pre-allocated, then it cannot be used for any other program. What if now we are running with two programs? That is, this memory is allocated for let's say this memory is allocated for one program, and this memory is allocated for another program. Let's say another program. So this is a program 1, this is a program 2. Okay. Now here, and this is a program 1. Now, in this case, what will happen that this, if we allocate this much memory already, then the remaining memory is very less that is available. All right. And if we want to have another data required into the memory, then we cannot give the space for that data because it is now pre-allocated. It is same like in a home. If we already, let's say we have a two rooms in a room, 2 BHK, let's say it is 2 beds, 1 hall, 1 kitchen. And if we already give, hello,
Sir, can you repeat from the start? I don't know, sir.
Okay. We are starting a topic. We are starting a topic called as linked list, and in that we will learn the. Please, इसका mic on है, please. Okay, now so in this case, memory organization is of two types. One is a static memory allocation and another is a dynamic memory allocation. In the static memory allocation, the memory is pre-allocated. That is, you assign them permanently till that program runs.
हॅलो सर.
हा
सुरुवातीपासून एक्सप्लेन करा ना सर परत.
हा सुरुवातीपासूनच करतो. हे सुरुवातीपासूनच आहे. याच्यापेक्षा जास्त काही सांगितलं नाही मी. ते थोडंसं बाकीचं सांगितलं होतं, पण दॅट इज नॉट पार्ट ऑफ सिलेबस. सो यू कॅन इम्पॉर्टंट इज लिंक लिस्ट ना. सो मी लिंक लिस्ट बद्दल सांगतोय, तर इथूनच सांगतोय, म्हणजे मेमरी ऑर्गनायझेशन पासून सांगतोय, म्हणजे हे पहिल्यापासूनच आहे असं समजू शकता तुम्ही. ठीक आहे.
ओके सर.
हा आता so we see that the memory is pre-allocated. In that case, what is happening that this memory, okay, that was used for the first program, and this much memory was pre-allocated. This memory. Now, in this case, what is happening that here this memory is already allocated, and what if now we want to have we want to give memory to other variables? Then in that case the memory available is very less. What if now this entire memory is allocated? Okay, and what if this entire memory is allocated? In that case, what will happen? So this entire memory is allocated. So there is no space available for the next variable. So can we do a technique in which we will give the memory as and when it is required? and we will remove the memory when there is no, it is not required. Okay, I mean we will remove the data from that memory when it is not required. So it is same like that, not pre-allocation of the resources. So how we can do it? So we can do it using dynamic memory allocation. In that, here the concept is that no fixed memory is pre-allocated. Memory is given when it is required. Okay, so in that case what will happen? So you might have seen some games, isn't it? And in that games, just like Half-Life game or some games that runs on a computer, so you see that it loads and then you do that, you play that games, and once the part of the game is done, then it again stops and again loads another part of it, another sections of it. Typically it is shooting game or something like that. Then in that case some scene is loaded. Okay, then how it is loaded? Okay, so previous scene is removed from the memory and the new scene is added into the memory. So that is what is the dynamic memory allocation, in which the memory is not given fixed, it is given when it is required. Okay, what if now if we have to load the entire program into memory, then memory required will be very huge, and that will increase the cost. So we have to reduce the, how do we reduce the cost then? So we can reduce the cost by giving memory as and when it is required, or giving the resources as and when it is required. So now how to do now then this dynamic memory allocation? How to do dynamic memory allocation? So one way it is done is using, it can be done using linked list. Okay, so now what is a linked list? So you can call this linked list is a, now you can define the linked list. It is a way by which dynamic memory allocation can be done. All right, so it is a way by which dynamic memory allocation can be done. Now what is the structure of the linked list? Structure of the linked list. So how does it look like? Okay, so it looks like very simple, in which it has a structure data, and it points to the next data. All right, so its structure is like this. So this is a one node. Okay, you can call this as a node. And here we will have another node of the same kind, and what will happen that this previous node will point to the next node. Okay, so and then this node will again point to the next node, again point to the next node if it is increased, and finally this node will point to null. That means it will point to nothing. So this will point to, finally it will point to a null. Okay, so it will point to null. Now then what does this node contains? So this node contains, as told to you, that it contains a data, so it contains a data, and number one, it contains a data, and the second thing, it contains the it contains the address of the next data. It contains the address of the next data. So that is, so this is the data and it contains the address of the next data. So that means this you can call it that it contains two parts. You can call this as two parts. This is the data, and this is a pointer to next data. All right. Now address means that it is a pointer. All right. Pointer means if I write integer a in C, then a is the data variable. Okay, a is a data variable. If I write integer pointer a, then a is the pointer variable, or you can call this as it contains the address, right? So it contains what it contains. It contains data, actual data, and it contains address. Okay, that is called integer pointer. Now, so in C programming language or C++ programming, now we will learn C++. In C++ programming language, we have a syntax like this, as it is told. Integer a to define the data variable and integer pointer a to define the integer pointer variable. So now how to define now then the singly linked list? Okay, so let us see. So first of all, we will try to understand now singly linked list, because we want to implement the singly linked list. So singly linked list means that it has the single pointer. Okay, so this single pointer it points. It is called as the singly linked list. Okay, in this case, this node is pointing to this. What will be the doubly linked list? Doubly linked list will be, now it will have two pointers. That is, this pointer, this will point to the next node, as well as there is one more pointer which will point to the previous node. So so it will be another pointer. Okay, so this is the doubly linked list. Okay, so now we have to implement the next assignment using singly linked list. So we will have only a single pointer. Okay, so that is this pointer from previous node to next node. All right. Now, so what will be the structure? So structure, you know that it is a data and it contains address of the next data. So now let us define the structure. So how to define the structure in the C++ programming language? You can do it using class. So we have a class, and then we will have singly linked list. Okay, class singly linked list, and then what will have a data. Okay, so how to define the data? So we have to have which data here? Data is that its PRN number and the name. Okay, so we'll have integer PRN and character name. Okay, so name of some 30 bytes maximum. All right, so this is the data. And what is a pointer? So it points to the next data of kind SLL. So we will have SLL pointer next. All right, so it will be the pointer which is pointing to the next data. So this is the data, and this is the address of the next data, or you can call this as a pointer. Right, so now let us implement this part in the programming language. So let us take C++ programming compiler. So let us take online GDB. Okay, is this visible? Dear students, is this visible?
Yes, sir.
Okay. Now, so you all know we have in C++ programming language, we need IOStream, which it contains cin and cout. So we are using namespace std, where it contains the definitions of cin and cout. Now here we will have a class. So let us take a class SLL, singly linked list. Okay, and here what we need to have? We need to have integer PRN. Okay, PRN is a number, and we want to have character name of some 30 bytes. and these are all private members. So if we don't write it by default, it is a private. Okay, and here SLL pointer next. Okay, so we'll have a next pointer. Now we'll have a public functions. Okay, public functions. Now here we will have one constructor SLL, and it will try to create the node. Okay, so what we will do now, we will ask to the users what's the algorithm. So algorithm is that we will do three things. First of all, we will add the contents or add the node in the linked list. Second, we will display the nodes or values. Okay, so we'll try to do only this part. Okay, let us try to do only implement this. So if we have to add a node, then what will happen that we will create one node. Okay, so how to create the node, you know it, that we have to create it. So we will create a node of this kind. Okay, so this node will be created. Now you know that it has two parts. It has two parts. So this is the first node that is created. Okay, so here we will have a data, and here also data are of two types. One is a PRN. So here PRN number will be there, here name will be there, and here pointer will be there. Okay, now we will create another data, another this one. Let's say this is created, and here we will insert some value PRN, let's say number 12, name is some Amit, let's say, and the pointer right now is pointing to nothing, so it will be null. All right, so let us create this node first of all, and let us point it by another node, which is let me share you the different screen, and so that I can draw it, or here also I can draw it. Let's paint. Okay, so that's better. I'll draw it. Okay, so we have this one node. Here there is a data. So data is the PRN number. So we will create another node. It will point to this node. Okay, so this way we will create. Okay, so it will have a data, the two data, and it will have again a pointer. We will create another node. So this will point to this node, and again the next node will be created. Right? So this and this will not point to anything. So this will be ground, or you can call this as null. All right, so this will be null, and this first node will be pointed by start, and the last node will be pointed by end. Okay, so we'll have two nodes. One is a start node and another is a end node. Okay, initially when we will try to create it, we have nothing there present. Okay, so we have nothing. So here, so once we create a node, so that node will be this node, and it will have this, and this node will be a start node, as well as this itself will be a end node. This will be an end node. So both are the same, that is start node and end node, and this will be a null. That is, it is pointing to nothing. So let us try to create that then. First of all, then we will need this start pointer and the end pointer. Okay, so that it can point it to the start of the linked list and the end of the linked list. or end of our this linked list. So we need to create this or declare these two variables. So how to declare it? So we only require single start and we require only single end. So when we require only single variables in a class, it's only single instance. Then how do we do it? Can anybody tell? Everybody has learned object-oriented programming concept. In an object-oriented programming concept, if you want to have an object and the variable should have only one instance of it, it should not have multiple instances based on the number of objects, then how do we do it? How do we create such a variable? Can anybody highlight on this? प्रश्न कळला का माझा? Question is very simple. Everybody knows static data members in object oriented programming? Does anyone know static data members? Hello students. Okay. Now, so we will use static members. So I'll explain or I'll write it directly. So we have a static SLL pointer start and pointer end. Okay, so we'll declare the static because I want only single instance of it. PRN name and next will have multiple instances based on how many objects are created. All right. So SLL is the so now SLL is the creator, or you can call it as an add node. Okay. So in the add node, I'll ask to the user cout /n enter PRN number. All right. So I'll take cin and in the PRN. Then I'll ask cout enter name, and let us take cin name. Okay, so it will go into this object PRN and the name. Okay, and we have to have the if it is a first node, then how do we come to know that it is a first node? Let's assume that the initial value of start and the end is null. Initial value of the start and end is null. That means no such list is present. Then that means the list is it is a first node. So we'll have here if start equal to null, that means it is the first node. It means it is first node. Right? If start equal to null, then what to do? Then we have to have start is equal to this. This means the whoever has called this function. Okay, the object. Okay, this is a pointer that points to the current object. Okay, so start equal to this, and end is equal to start is equal to end is equal to this, because end is also pointing to the first node. Start equal to end equal to this. If it is not the end node, or there is some node created, if start is not null, then in that case we have to have end ka next. So this is a next pointer. So end next is pointing to our current node, this, and end is equal to this. Okay, so end will now shift. That means we will have, that means here that means we already have one node. Let's say assume that. So we have one node. So in that case, what will happen, that this will be a start node This will be end node. And we have created one more node. Okay, so this node is created. Then what we have to do? We have to take end. So this is the end is pointing to this. So end next should point to this node. All right. So that is what is we have done using this. End next equal to this. So this end next is equal to this, and end is equal to this. So now end will now point to this. So end is equal to this. So end will now shift to this node. Now, if we have another node that is created, so what will happen? That those second node will be created. So this end should point to this node. Okay, so this node is pointed, and end should now point to this. Okay, so end will not point to this now. It will not be point to this. So it will now point to this. So that is what end equal to this. Okay, and here we have to have
कंडीशन फिर से बताए ना.
just a minute. And we have to have next is equal to null. That's काय करायचं?
इस कंडीशन परत सांगा ना सर.
else condition सांगितली ना, हीच else conditionच explain केली आता.
परत सांगा सर.
हो परत सांग. इनिशियली तुमची लिस्ट एम्प्टी आहे. ओके, म्हणजे काय सिच्युएशन आहे, तुमच्याकडे काहीच डेटा नाही आहे. जेव्हा तुमचा पहिला नोड ऍड झाला, हा नोड ऍड झाला, ह्या नोडला कोण पॉइंट करताय? स्टार्ट पॉइंट करतोय. आणि कोण पॉइंट करतोय? एंड पॉइंट करतोय. स्टार्ट पण हाच आहे आणि एंड पण हाच आहे ह्या नोडला. नाव आता मी दुसरा नोड तयार केला. मग या केसमध्ये स्टार्ट नल आहे का? नाहीये, कारण तो ह्या नेला पॉइंट करतोय. मग माझ्या केसमध्ये काय करायचं? मला ह्या नोडला हा नोड अटॅच करायचा आहे. सो हाऊ टू अटॅच इट? सो याला जोडण्यासाठी काय करायचं? एंड का नेक्स्ट, हा एंड आहे, हा एंड का नेक्स्ट इज इक्वल टू दिस. सो हा धिस आहे, हा धिस आहे. Okay, so that is what we have done using this end ka next equal to this, and this end is equal to this. So end is now pointing to this node. All right, so that is what we have done using this. Now done. So we have successfully created the node, and we have successfully added the node. Okay, now we'll write one function to display the linked list. Okay, so how to write it? So just write a display function, void display. Okay, and so here how to display it? So we will start from this pointer, and we will print the data into this into this node, and then we will go to the next node and then print the data. Again, if there is a next node, then go to the next node and print the data, and go till it is null, till you get the pointer null. Traverse that. Okay, so we'll have a pointer. So SLL pointer is equal to start. Okay, so we'll start from the first start pointer. Okay, and while ptr not equal to null, till it is not null, what we have to do? We have to print the data. So ptr, so I'll have cout this, and what we have to print? prn, then the name. Okay, we have to print the prn. So ptr ka prn, ptr is the pointing to that node, so ptr prn, and then followed by comma, followed by the name. Okay, so how to access the name? So ptr name. All right, so this you can access it. So this is an access operator for pointer. All right, and a dot operator, dot is used for the static object, and ptr is used for the dynamic object. Okay, so if it is a pointer variable, then you must use arrow, and if it is not a pointer variable, if it is a data variable, then you have to use a dot. That means this, you all know that this class concept. Okay, so I need not repeat it. Okay, so you got a ptr name, and then finally let us close it, the box. Finally, let us have arrow, and this arrow, and this will again point to this one. And once the while is done, so I'll see out that it is pointing to null, last one. Okay, so let us print this one, and once it is printed, we have to go ptr is equal to ptr ka next. So we have to go to the next node so that to print it. Now done. So we have successfully created the create function and the display function. Now we have to just create now a menu driven program. Cout /n menu. Let us have /n one dot add node in SLL singly linked list and /n two dot display list. Okay, and let's have one more /n3 dot exit. Okay, so this is a menu, and we'll take the choice. So let's have integer choice, and then so we'll have a switch choice. It's like if and else, which means the if and else cases. So case one means which one? Add a node in singly linked list. Okay, so we need to call the object. So let's have a pointer SLL pointer obj, let's say object, and we'll have a obj calling a function, or obj is equal to new SLL. So automatically it will call the constructor. Okay, new SLL break case 2 display. We have to display the so we'll call it obj display. Right, so we call the function display, and finally break, and case 3 is exit. Case 3 is exit. All right, so now that's it is. So we have successfully now written a menu driven program. So now only thing remaining is that we have not yet declared the initial value of the start and the initial value of the end. That has to be null. So how to declare it? So we can declare it like this. So we have a SLL pointer SLL. How to access the public variable of the SLL? You can access it using access specifier. Okay, so this is the access specifier start equal to null, and SLL pointer SLL end is equal to null. Initially both the values are null. Okay, and once it is done, then it is created. It will point to the next node. Okay, so now let us run it. Let us see whether we are successful or not, and let us see any errors that are there in your program. Okay, now there is an error. So we have forgot the semicolon at line number 13. So let us see where is the line number 13. We forgot it here. Let us put a semicolon. Again run it. Yes, PTR name. In our case, name is N capital. So N, we got it. Again run it. Now here SLL pointer, it is telling that yeah, it is not yet finished. We have to finish the class using end class. So this is must. So we have finished it. Now exit. We need to pass the value into it, how it is exit. So that's it is. Semicolon. Yes, semicolon. Yes, now, yeah, let us make it. Add a node in. We have not written enter your choice. Okay, so I'll just see out. See out /n, enter your choice. Let us run it.
Sir, return 0.
Okay, now add a node 1. Okay, enter PRN number. PRN number is, let's say, 12. Amit. Now here exit code, something error has happened. Okay, let me see what is the error.
सर आपने return 0 नहीं लिखा है.
Return 0. नहीं,
Return 0 नहीं लिखा है.
there is no need. It is exiting from here, so there is no problem. There is no problem. Our program is exiting from here. I have to just see SLL pointer start, pointer end, SLL, enter PRN. So we are getting C in, PRN, C out, enter name, C in, name. Okay, we got a name. And next is equal to null. Start equal to null, start equal to end equal to this, end can next equal to this. Done. Now obj is equal to new SLL, break. Yeah, we haven't made a while. Okay, so we have to continue it infinitely till it user say exit. Okay, so we have to continue this while 1. Okay, so let us run it. Okay, add a node, enter your choice 1, that's it, 12. Amit, successfully added. It should ask you the enter a choice. Actually, while 1 should come, Control X, it should come at here. Yes, correct. It should again print the menu and again get the choice. Yeah. Now enter PRN. I'll put a semicolon. Colon. Now add a node in SLL 1. Let's say PRN 12. Amit. Again add a node 1. Enter PRN 15. Let us put a name Vijay. Again add a node. Let us put a PRN 20. Let us put a name Sachin. And now let us try to display the list too. So this is a list. So we got a list. First is 12 Amit. It is pointing to 15 Vijay. It is pointing to 20 Sachin. And then there is no any further node. Then it is pointing to null. Okay. So we have now correctly created the linked list. Okay. Now if we again add a node, let's say we add a node, that node will be added at the last. Let us add the node one more. Let us have a PRN number as 5. And the name is, let's say, Kohli. Let us display it. Now Kohli got added at the end. Okay, so 5 Kohli. Got it? So this is the linked list that is created. If we again add it, 1 add. And let us put a PRN number as 67 and the name as, let's say, Shankar. And let us try to display it. So we got it properly. Okay. So our two functions are properly running. Add a node in SLL and display the list in display the list. So we are correctly displaying the list. Now let us exit it. Now one more thing they told it that delete a node. Okay. What if now we have to delete a node? So let us take a. Let me tell you the logic first. How will you delete it? And then we'll try to implement that logic. Now here I told you that we have now this list. Sorry. So we had this node in which this was a data. So PRN number, let's say 5, and name was Sachin, and it was pointing to the next. It is a next data. It is pointing to the next node. Okay, so this next node. Again, it has 3 compartments: PRN, name, and the next pointer. So PRN was something 15, and its name is Kohli, let's say, and it is pointing to the next data. And let's say the next data is again okay. So it has 3 parts, and number is, let's say, 6, and it is, let's say, Vijay, and it is pointing to nothing. So the next is now null. Now, how do you know that this is pointed by start? So the first pointer is that it is pointing to here. So start is here, and end is the last. So this is the last one. Now, suppose we want to delete any node into this. How do we delete it? Now, let's say it is asked to delete 5, node number 5, or having a PRN number 5. So you come to know that it is a first node. Okay, so it is a first node. So what you do, you just make this as a start. Okay, so start will now move ahead. So start will be this. And what you do, you delete the node. You delete this node. Okay, so now this node will be deleted. That means this will go, and then this is a new start. And so we have a list starting from here till null. Okay, so let us now try to only delete now the start node, and then we will delete the intermediate node and as well as at the end node. Let us see different logic for all these together. So we'll not see the entire logic at one moment. We have seen the logic only for deleting the start node, and we will implement that. Okay, let us try to implement it. So let us have a delete function. So void delete, and for delete we will ask to the user cout enter PRN number to for to delete, to be deleted. Okay, so we'll try to get C in. Let's say that is the PRN, small PRN. All right. And now we'll try to search the PRN within the list. Okay, so first of all, we need to search it. Okay, so that means here, luckily that was the first node that we got it. What if now it is not got it? Let us see Control Z. Okay, Control Z. So now let us see, we want to delete the node number 15, let's say. Okay, the next we have to delete is, let's say, 15. Then how do we delete it? So we'll start from this node and we'll see whether 15 is there or not. It is 5 and it is 15, so it is not there. So we will move ahead. Okay, so we'll have one more pointer, PTR, let's say, or PTR pointer. So PTR will now point to the next pointer or next node, and we'll check it whether PTR data and our data that means to be deleted is matching or not. If it is matching, yes, then it is deleted. It is to be deleted. So first of all, we need to do a searching. Okay, so how to do a searching then? So let us see the searching. So we have PTR is equal to start. Okay, initially we start from the pointer. Okay, and so we will continue it while we will continue this while PTR ka PRN is not equal to PRN. Okay, we will, what we will do, we will move ahead. PTR is equal to PTR ka next. We'll move to the next node. Okay, it is the first node that is pointing. If it is that data is there till it is not matched, then move ahead. PTR is equal to PTR ka next. Now So here now it is a searching. So we have successfully now done a searching. This is searching for PRN, right? Now once it is done, we will check it if PTR equal to start. If it is the first node, if it is a first node, is it a first node? That means PTR, let's say 5 is to be deleted. And then PTR equal to 5. So PTR ka data is 5 number PRN, and the number to be deleted is also 5. It is matching, so it will exit. And then the PTR will point to now start. So if PTR equal to start, then what we have to do? We have to move start to the next position. Okay, so start is equal to start ka next. So it will move from here to here. Okay, so start will be now pointing to this node. And then what we have to do? We have to delete PTR. PTR is pointing to that node, delete the PTR. All right, so let us now try to run this code, only delete part, whether we are successfully deleting or not. Let us try to see it. Let us add into this 3 number is now delete, and the 4th number is now exit. Okay, so let us have case 3 as calling a function. Case 3, it is calling a function called as delete. So we need a object to call it. So object delete, and case 4 is exit. So now let us try to run it. Now here it is PRN was not declared, so we have to declare it. What PRN is in the delete function. Yeah, cn PRN. So it is an integer type, so we need to have integer PRN. Similarly, we have used PTR. PTR is SLL pointer, so we need it declare as SLL pointer PTR. All right, now run it. Okay, there is no error. Now let us add a node 1. PRN number 12, name Sachin. Let us add one more node, PRN 15, Vivek. Let us add one more node. Let us have a PRN 20 and name Vijaya. Okay, now let us try to display it. So it is properly displaying our list. 12 Sachin is pointing to 15 Vivek, pointing to 20 Vijaya, and then there is no any node pointing to null. Now we have to delete the first node. Okay, so let us have 3 delete function and enter PRN to be deleted. The PRN to be deleted is 12. Okay, now here it has got some error, or let us see. I think have we put a break properly? No, we haven't put a break. So break has to be there. And we will write a message here. Once it is deleted, cout /n, the node PRN having PRN is successfully deleted. Right? So let us put that message. Now let us run it again. So add a node in SLL 1. So PRN 12, Sachin 2. Let us try to display only Sachin is there. That's correct. Now one more one. Add a node. Now add one more node. PRN is 34. Enter. Let us put a name Ashok. Let us display it. Yes, Sachin is pointing to Ashok. That's correct. Let us add one more. 50. Let us put a name as Satyavan. Now let us try to display it. Yes, Sachin is pointing to Ashok. Ashok is pointing to Satyavan. And it's correct. Now let us try to delete the first node. 3. PRN 12. The node having PRN 12 is successfully deleted. Okay, now let us try to display it. See here, 34 Ashok, 50 Satyavan, and null. That means our Sachin got completely deleted. So we see that it is not there. Okay, so we successfully deleted the first node. Now, what if now we have to delete the intermediate node? Then what to do? Okay, intermediate node. And what logic to be applied? So we have now this node, and this node. Let us have Control Z. Let us have 4 nodes. 1, 2, 3, and 4. Let's say there are 4 nodes, and they are pointing like this. Okay, so it is pointing to this, it is pointing to this, it is pointing to this, and it is pointing to null. Now let's say this data is 5, this data is, let's say, 10, this is 15, and let's say this is 50. And now we want to delete a data called as 15. Okay, the 15 is to be deleted. We want to delete the 15. Okay, so what logic we applied? First we did a searching. Okay, so this, you know that this is the start pointer. I write it as only S. S means start, and this is the end pointer represented by E. Okay, this is the end pointer. Now we have one more pointer called as PTR pointer. Let us name it as P. So I see that P ka data or P ka PRN is that's the one we have to delete. No. So PTR will move ahead. So PTR now will come to this node. Okay, P will come to 10. Same thing, it will say that it is not there, and P will now point to here, this, and it says that yes, it is the data that is to be deleted. So then what we have to do? We have to delete this. So then we have to point from here to this. And then we have to delete this. So now how to do that then? So to do that, we need to have the address of the previous pointer of the data which is to be deleted. Now here 15 to be deleted. So we need to know the pointer here, previous pointer, so that I can say that this connext is equal to PTR connext. So PTR connext is this, and the previous connext is this. Okay, so we'll have one more pointer called as previous pointer. So previous pointer is a one which will point to the previous node. So now we got the logic. So now let us see. So now let us have delete. Let us come into delete. So we'll have one more PTR now, previous PTR, called as pointer previous. Okay, so previous initially will be null. Okay, and if it is moving ahead, then previous will point to the PTR. It will store the previous value of the PTR. Okay, so previous is just behind, just before the PTR. Okay, so if PTR equal to start, then we did this. If it is not,
Now, what if now we have to delete the end pointer? First of all, now we'll write for end also. Now this is in between. What if now we have to delete the end, and if ptr equal to end, if ptr equal to end, then what we do? We will shift end to back. So end should come to back. Okay, that means if ptr equal to end, if it is an end pointer, then what we have to do? End is equal to previous. Previous is now ptr is this and previous is this. So we keep a track. Okay, so end equal to previous and end ka next equal to null. And we have to delete ptr, and we have to write down that this is successfully deleted. We will later on combine all these things just to have a separate cases. So I'm writing the whole code again. We will reduce this code later on. All right. Now, and if it is not, else if it is not the end, then it could be the else. It could be the in between. If it is in between, then what we have to do? Previous ka next is equal to ptr ka next, and same thing, delete ptr and so delete ptr, and the node having prn is successfully deleted. Okay, so now we have written the logic for the start, we have written the logic for end, and we have written the logic for in between node also. Now let us try to run it. Now let us add the node 1. PRN is, let's say, 14. Name is Satyajit. Let us add one more. PRN is, let's say, 16. That is, it is Vishwajit. Let us try to display now. Okay, so Satyajit is pointing to Vishwajit. Okay, and now let us add one more. 1. Let us put a PRN number as 18. Let us put a name as Ratnakar. Now display it. So we got Satyajit, Vishwajit, Ratnakar, and let's add one more into it. Let's say put a PRN number as 25, name as Vinayak. Now let us try to display it. So Satyajit pointing Vishwajit, Vishwajit pointing Ratnakar, Ratnakar pointing Vinayak, and Vinayak is pointing to nothing. Okay, so now we have to delete one by one. Okay, so let us try to delete the first node first. 3, let us try to enter a PRN number to be deleted. Let's say 14. So 14 is successfully deleted. Let us try to display it. So successfully deleted. Okay. Now we'll try to delete the last node, which is 25 Vinayak. Okay. So let us 3 PRN 25. So the node having PRN 25 is successfully deleted. Now let us try to display the list. So we see that the Vinayak got successfully deleted. Okay. Now we will add one more into it. 1. Let us add PRN 30. Let us put a name as Abhijit. Now let us try to display the list. So now Vishwajit pointing to Ratnakar, Ratnakar pointing to Abhijit. Now let us try to delete 18 Ratnakar, whether we are successful or not. Okay, 3, 18. The node having PRN 18 is successfully deleted. Now let us see the list. So we got the 18 deleted, 16 Vishwajit pointing to Abhijit. So we are successful in deleting any kind of node. Now only thing remaining is that what if now that node is not present? That means not found. That could be the case also. Okay, so that we have to see it, how we can write it. First of all, now how to remove now this one. Okay, delete PTR is present here, delete PTR is present here, delete PTR is also present here. Can we combine it only one? Okay, so we can have it here. So what we have to write down now a case in which it is not present. So if PTR is not equal to null and if it is not null, then only we can access the PRN. Otherwise, we cannot access the PRN. Okay, otherwise that will be error. So if PTR equal to start, PTR equal to end, PTR else if PTR else if PTR not equal to null. That means some value is present. Else means that it has traversed everything and it has become null. PTR has become null. Then we can write down C out the PRN to be deleted does not exist in the list, in the linked list. All right, so that's the message that it is not present. Now we have to what we have to do. So here we have to combine it. So how to combine it? This part I'll not write it here. Control X. I'll write it at the end. Okay, so if this is in while, if, else if, there is no need of then, else if. Yeah, else if I'll directly write down here if PTR not equal to null. If it is not null, then do all these operations. If PTR not equal to null, then do this. So then there is no need of else if PTR not equal to null. Else what we have to do? We have to write down else we have to write down that PRN the PRN does not exist. That if PTR has become null, that means it is not, searching is not successful and therefore it has become null. Now I can write down, I can just remove this from here, Control X, and let us remove from here also. Remove from here also. And just put at the after everything, Control V, delete PTR, and this is for one if that we have deleted it successfully. If it is not null, then delete it. If it is null, then that means it does not exist. Now let us try to run it, whether we are successful or not. Okay, so let us add a node. in singly linked list having a PRN 13, name Amol, add Ramesh, let us run it again. PRN 13, Amol, add a node, PRN 15, Ramesh, add a node, let's say the PRN is 30 and name is Akshay. Now display the list. So Amol is pointing to Ramesh, Ramesh is pointing to Akshay and null. Now let us put a number which is not present here. Okay, so delete and put a number which is 20, which is not present into the list. So it is showing that the PRN to be deleted does not exist in the linked list. Now again see the list display. We are seeing the same list again. Now try to remove the Ramesh. So Ramesh 3, number 15. It is successfully deleted. Now try to see the list. 13 Amol, 13 Amol, 30 Akshay properly. Now try to remove the first node, which is 13. 3 PRN number to be deleted. Let's say 13. Successfully deleted. Now see the list. It should see only one data or 30 Akshay. Correct. Now try to delete that itself also. 30 Akshay also. Then what is our output? 3. 30. Okay. The successfully deleted. Now try to see the list. 2. It is showing null. That is nothing is present into the list. So it is null. All right. So we are successful. We have successfully implemented the singly linked list. Okay. So have you got it?